All right, sorry about that. Okay. So I made my Boggle folder. I'm gonna make a main.py. I'm gonna put all my code. Okay. So just to review what I'm trying to do here. So in Boggle, we've got 16 six-sided dice. They've each got 6 letters on them. I need to be able to shuffle the dice, roll each of them, and then put each of those dice into one of the 16 squares of our 4x4 Boggle board. Okay, I know the exercise description was fairly verbose, but in a nutshell, this is what I'm trying to do here. So first up, I'm going to define my class. Just call it Boggle board. Not feeling very imaginative. Pretty much every class in Python is going to need an init method. So I can do stuff when I instantiate my object. So now I'm trying to think of what I need to keep track of for my Boggle board, what data it needs to store internally. So I need some representation of the board. And I'm not exactly sure yet, but that's probably going to be a list of lists. You know, I've got rows and columns. So I'm going to start that out as an array. Probably also going to need some dice. I know I've got 16 of those. So that's also going to be a list of some sort. What is with my editor? Just a list. Okay. Let's see. We know that there's going to be a shake method. So I'll just define that. We'll worry about the definition in a second. And this is not actually part of the requirements, but it says that you need to be able to see the Boggle board. You need to visualize it. So I'm going to make a method that just prints out the Boggle board to the console. Because this is not a fully interactive game. I'm just building the board here. So I'm going to make a method show board. Okay, so we'll figure out what this method actually does when I actually have a board to show. But this is the general structure of my class. These are the things that I think it needs to know. And these are the things that it needs to be able to do with what it knows. Okay, so our Boggle board is 4 rows with 4 slots in each row. So I'm going to just put 4 arrays in here, 4 lists, if you will. And then in each row, so there's 4 items in each row, but part of the requirements, it says that we should just have dashes in there to start. It says that when we try to visualize the board before we shake it, it should just show, 4 dashes for each row. So I'm actually just going to hard code that in here. So this is my basic Boggle board, just 4 rows of all dashes. So I just want to make sure that what I've done so far actually works. I haven't made any mistakes yet. So I'm going to fill out the show board method just so I can verify that this is a board that can show it on the screen. It looks like what the requirements are asking for. So I'm just looping through all the rows. because I want each row to be on its own line of output in the console. And then we're going to print basically just printing each row, but I'm gonna format it a little bit because I don't want to print the row as a list. I want to print it as a string. So we're going to use the join method to say that we're joining this list on empty string. We could choose any separator character, maybe put spaces between the list items, but I want them to be snug together. So we're going to join that on an empty string. So I'm going to test that out real quick, see if any of this actually works. Say game equals Boggle board. And then we'll just call Boggle dot showboard. I mean, new game dot showboard. All right, let's see if this does anything. And it does not.
Do you need to return? So you're, well, you're printing it. Let's see.
Because of the extra comma on row 14.
Your tabbing
You're
is off,
inside the
right?
init method.
Is there a reason
Is
that
it?
you put the
Ah,
shake and the showboard?
that's-
Yeah.
That's it. I'm not sure who yelled it out, but someone had the right answer there. Both of these methods were defined inside of init. So it is valid code, which is why I didn't throw an error. I'm initializing the object, and then while it's initializing, it defines these two other methods, but they weren't defined as instance methods. I just kind of defined them and did nothing with them because they were inside of init. So now that my code is properly indented, this should actually work. See, this is why we test frequently while we're developing. Okay, cool. So that looks like what I was expecting. Yeah, you might notice that I don't ever write code for more than like 10 minutes at a time before I execute it and make sure that it actually works the way I'm expecting it to. It's just really easy to make little mistakes and then easy to build bad code on top of bad code if you've made one mistake and then you build off of that mistake. So I like to execute my code frequently, see what it looks like. Anyway, so this is my Boggle board. That's what I was expecting. So now what I want to do is actually get some dice that I can shake, dice that I can roll, and then put into these slots instead of just the blank dashes. So, see, I'm going to go to the exercise description real quick. So these are all the dice. Just going to copy these real quick. Got to indent those. And then we've got to actually make these into strings. So just excuse me for a moment while I format all of this. So I don't know if any of you know about this feature, but you can have multiple cursors in VS Code. I don't do this very often, but this is one of those times where it's kind of useful. If you hold I'm doing this on Mac, if you hold the Option key and then click in multiple places, you can get multiple cursors. So now I just press open quote once, and it puts it on all those lines. Go to the end, end quote, and a comma. So now this is actually valid code without spending 20 minutes just typing and clicking around. So those are all of my dice. There are other ways I could have represented them. If this was going to be a more complicated program, I probably would have made a separate class just for the dice. But in its current state, it's not going to get too tricky. So I think I can handle it just by representing them as strings. And then just for clarity, each of these strings is 6 letters long. Those are the 6 possible sides of the die. So if I can just get a random letter from any of these strings, that's effectively rolling the die. All right, so I've got my dice, I've got a board. So let's shake some dice. So there's a few things that need to happen. They can kind of happen in any order, but I need to shuffle the list of dice because I don't want to always have this die in the first slot and this die in the last slot, because then, there's only 6 different letters that could appear in the last slot. So I need to shuffle the whole list of dice. Then I also need to roll all the individual dice. And then I'm going to take those letters from the dice that I rolled and then put them into the Boggle board one at a time. So first, got to keep track of the letters. So after I roll an individual die, I'm going to put the result of that roll in this letters array. And then afterwards, I can put all these letters into the Boggle board. Now I want to shuffle my dice. Now there's a built-in library in Python that does this for you. So I'm going to import random. Random is a super useful library in Python for lots of random choice kinds of things. You can just choose random numbers, random items from arrays. And it has a bunch of other use cases that I'm not thinking of at the moment. But basically, any problem that you might have that involves choosing a thing at random numbers, or random samples even, so you can do some basic statistic kind of work with this. The random module is very useful. Note that this is very different from JavaScript, which does not provide you all these useful utilities. In JavaScript, all you can really do is get a random float between 0 and 1, and then you have to do math in order to like convert that into an array index in order to get a random item from an array. So that's honestly part of the reason why I'm doing this in Python, because I think that the random selection is easier in Python than in JavaScript. But I could have done it in JavaScript just as well. All right, so as I was saying, got our letters. So now I imported the random module. So I'm going to shuffle the dice. Let me just make sure that that actually did something. So I'm gonna print self.dice. I want to see what this looks like after I shuffle them. Oh, I never shake it. So I actually have to call that method to see that do anything. New game dot shake. And then after I shake it, I'm going to show the board again. Okay, but one other little thing here. I'm going to put an extra print statement at the bottom of show board just so that there's a blank line afterwards, just for formatting. So, if I show board twice, it doesn't look like just 8 blank lines next to each other. All right, so I shake, those are my dice. I shake, those are my dice. So it looks like this is working correctly. I'm getting different dice in every spot every time I run the program. So it seems like we're actually shuffling. That's definitely a bug that you might find sometimes, is you think you're doing something randomly, but you're actually getting the same results every time. So, you'll have to investigate why the random functionality is not doing what you think it is. But that's not happening here. We're actually shuffling the dice successfully. So I'll move on to the next part of the challenge. So after shuffling the dice, I'm going to loop through them. And now I want to get a random letter from the die. So remember, each die is a string of 6 letters. And now it turns out that there is another method in the random module that helps me, pick one of the letters out from the string. So that is random.choice. You pass it any iterable thing. So like a list, a tuple, I think a dictionary would work as well, or even a string. And then random.choice will give you one random item from that iterable thing, from that list. So that's one kind of tricky thing about Python and programming languages in general, is that in many cases, strings are kind of treated like lists. Any of the like searching that you might do through lists or mapping, or, choosing random items, lots of functionality that you might do on a list, you can also do on a string, because sometimes you can just think of a string as a list of letters. So that's kind of what we're doing here. So random.choice is going to give us a random letter from one of the 6 sides. And then I'm going to store that random choice in our letters array. So I'm not just calculating it and doing nothing with it. We are appending to the letters that random die. So if I've done that correctly, our letters array should now be 16 random letters from each of our 16 dice. I'm just going to look at that real quick. Excuse me. Cool. So here's 16 random letters. WGRDT. Do it again. KREO. Korea. So it looks like we're actually getting 16 random letters every time. I don't see any patterns here, other than, the patterns inherent in the dice, like anyways. So I don't see any patterns. Looks like we're randomly getting 16 letters. So the last thing I need to do is take these 16 letters that I rolled and then put them into the 16 slots in my Boggle board. So I'm going to loop over the rows in my board. And then I'm going to loop over the columns in each row. Now, no, I could have just said like for I in range 4, for J in range 4, but in this case, I wanted to use more meaningful loop variables to help me keep track of which loop is which, the outer loop versus the inner loop. Rows and columns are more meaningful to me. So this helps me keep track of what I'm doing. And then here's the one line where all the magic actually happens. So we're going to assign this one square of the board with the letter from our letters array. So we first index into the row, and then that row is itself an array, which has 4 items in it. So we have to index into the column of the row. Now we're going to assign it a value. It's just the last letter of the letters array. We're going to pop it off. So that in the next iteration, we can just pop off the next one at the end. And then in theory, at the end of this loop, we'll have looped 16 times to pop off all 16 of our letters. So we'll have an empty letters array and a full Boggle board. Cool. So looks like we got a Boggle board. I'm going to run that again just for my sanity. Looks like we have a different Boggle board. Run that one more time. We have yet another Boggle board. I'm going to put another shake call into the same execution of the program, just to show that it can shake twice without having to restart. So yeah, we get 2 different Boggle boards. So it looks like I am randomly rolling dice, randomly putting them into their slots, getting a random Boggle board. So now we're ready to actually play the game. If I was going to do phase 2 here. Do we have any questions? Wow.
Just a very basic question. So when you first created the the list of all the dashes. Like, how did you like make them print out in different lines again?
So I'm doing a loop over self.board in show board. So it's doing 4 iterations of the loop. Is that right? Show board, yeah, 4 row in self.board. So in the first iteration, it's just printing this. Then second one is this, third is this, fourth is this. So there's 4 separate print statements, and print just always adds a new line. So that's like here, I put a single empty print just because I wanted a line for space. You know, I could put like 10 of these here if I wanted to. And now there's just a lot of extra space after it does show board. Because print always adds a new line. So
Okay.
just because I have 4 print statements, that guarantees it'll be on 4 lines. Does that help?
Okay, so you're pretty much like print each list every time, and you print empty space before you go to another one.
So
I'm sorry.
print automatically adds a new line. Like there's no way I can have 2 print statements that are on the same line. You know what I'm saying?
Okay.
Jesse?
Yeah, a quick question on line 45, 4 row and range. And so I'm just trying to understand. So we're iterating just through the number 4 for row and just through the number 4 on column. And then we're going to be putting that, and then that's being stored on the self.board row column. And then the letters are popping. I'm
Right.
just trying to understanding it.
Yeah, so so range 4 is, it's basically a list of every number from 0 to 4. So I mean, let's just say so let me just show you real quick what that looks like. So this is what we get when we just print range 4. It's just the numbers from 0 up to 3, which conveniently, those are the indices of my rows. And also, because I've got 4 rows, and also those are the indices of each column in each of my rows, because there's 4 columns per row. So, you know, in the first iteration, row is going to be 0, and then column is going to be 0. So self.board 0 bracket 0 is, so this is self.board 0, this whole array here. And then self.board 0, 0 would be this first item here. So then, you know, further on through this loop, you know, let's say we get to row equals 2 and column equals 3. So self.board at 3, or self.board at 2 at 3. Well, so self.board has 4 rows, 0, 1, 2. So this is index 2 of self.board. And then this is itself an array. So index 0, 1, 2, 3. So this is index 3 of index 2 of self.board. Is this coming together?
Okay, and then it'll and then that particular area will equal whatever is popped from the letter array.
Right, because I'm just assigning to it directly.
Okay, I'm understanding. It's coming.
equals-
It's coming together.
Cool, cool. I'm glad. Shun?
Yeah, I just have a question about the random dot shuffle.
Yep.
So that shuffles or that mixes up the original list, right?
Right.
Rather than, okay, cool. Yeah, that's
Yeah,
right.
this is a destructive method. You can correctly assume that because I'm not assigning this to a variable.
Yeah,
If this
right.
was a non-destructive method, this would be completely useless because I'm not capturing the return value. But yeah, you're right. This is a destructive method. Yeah, which is different from some of the random methods, like random.choice returns a new item. I guess it wouldn't really make sense for it to modify the original though. Any other questions, Jesse?
On that same area that he's talking about, can you just go over real quick over the, was it the choice method and the shuffle method? Is that just for Python itself in the random?
Yeah, these are specific methods to Python from the random library. They
Okay,
just make it easier for you to choose things at random. So
Okay.
like random dot, for just a very simple example. Excuse me. Oh, right. Needs to be a list. Okay, so I'm passing in a list. And so every time I call it, it just picks one random item from the list, except C for some reason. There we go.
Okay. We gotta get used to these new methods. I'm still learning more about Python, so, okay. Perfect.
But yeah, don't get too accustomed to these new methods because again, in JavaScript, all you have is math.random, which gives you a random number between 0 and 1. And so you have to like multiply that by the length of your array and then chop off the decimal and then use that as an index. There's like a few steps you have to take. So I appreciate the random functionality that Python provides. This is one of the few things that I think Python does much better than JavaScript. In general, I'm a big JavaScript fan.
Thank you.
Marcus?
So if you use the random module in this class and then you import this class into another file, do you have to import the random module again?
No.
Okay.
So only if that other file like explicitly used the random module, like named it like this. But if you're just importing a module that imports another module, like it's sufficient that the second module imports it. Like, trying to think of how to describe it. Like I almost think of it as like threads that are connecting the different files together, or maybe even like pipes kind of that are connecting the files together. So it's like not everything needs to directly connect to everything. But maybe this isn't actually such a great metaphor. But yeah, so the short answer to your question is that only the files that are directly using some other module need to import it. It's totally normal that you'll have like one module that imports some other module, and that second module imports like 16 other modules. But the first module doesn't have to worry about the 16 smaller modules. You just have to think about the one thing you imported. So this is one way we can kind of separate concerns, save us from thinking about a million things at once and just kind of focus on the problem at hand.
Sounds good. Thank you.
Sukhdev?
Hi, do you mind going over the random.shuffle and random.choice under the shake just one more time? Walk through what it exactly does, please.
So let's look at random.shuffle first, because I think that's a little bit simpler here. So basically what it does is it shuffles the array like a deck of cards. It just puts the items into a different order. So for a really simple example of that, get random.shuffle. I don't know. Excuse me.
it's mutating it, so I don't think it'll actually print it.
Yeah, you're right. And I just told you that like 5 minutes ago. So let's try this again. Wait, okay, sorry, I keep forgetting I'm not doing JavaScript here. Random dot shuffle numbers. Okay, this is how you write code. There we go. So every time I call the shuffle method from the random library on numbers, it changes the order of all the items in the array. So then when I print it again afterwards, they're not in the same order, which is what we want for a fair game. We need to have the dice be in an unpredictable order. Because it's true that we're rolling the dice themselves, but the thing is that each die doesn't have 26 letters on it. There's only 6 sides. So if we didn't shuffle the dice, then that would mean that the first square can only have an A, an E, or G, or an N, because those are the only sides on that die. Because again, in order to choose letters from my dice, I'm just looping straight through the dice array. So in order to not get that in the same order every time, I'm shuffling my dice array first, and then I just loop straight forward. In general, I don't like doing like really fancy for loops where you do anything other than loop straight from the back to the front. Because there are ways that you can change your loop variable in the middle of a loop to go backwards and forwards and all kinds of weird things and break and continue. I try to avoid doing that as much as possible. I'll just manipulate the array beforehand so it's in a good shape for me to just loop straight through. Do a simple loop like that. Sorry. So does that answer your question about shuffle? You want to talk about choice now?
Yeah, I think the shuffle is good. I'm just for the choice. I'm just trying to figure out exactly what it's choosing. Is it choosing that sequence, that string, or a letter within the string?
So choice will choose one thing from the list you provide it. So maybe it seems a little intuitive because die in this case is a string. So let's get some prints open there. So each die is this string of 6 letters. Then the random choice, when I pass in the die, gets us just one of those letters. So this is what I was saying before, how in many ways you can treat a string as a list, because in one sense, it's a single thing, it's one string, but in another sense, it's a list of individual letters. So in this case, random.choice is treating our string like a list of letters, and it's picking one letter out of that string. So this is how I'm choosing to roll the dice. And again, if the game was more complicated, I would probably make a dice class that have a roll method that can choose one random face from their 6 faces and then return that. That would have also been a good option, but I thought this program was simple enough that I could get away with just doing this. And it seems to work for what I'm doing. Does that clear things up for you?
Yes, it does. Thank you very much.
Cool, you're welcome. I think I saw some other hands go up.
No, I raised my hand, but it's kind of a tangent. It more with this random method, you have each character's 8 bits, so 1 byte. So when you say like 256-bit encryption, is it kind of doing this 32 times with like 32 different choices and mixing up your characters?
Um. I want to say no, but I don't have the actual correct answer for you. Let me get back to you on that. Let me make a note real quick.
I know that's random. It just kind of popped in my head.
So you're saying in the phrase, 256-bit encryption, what are those bits referring to?
Well, like behind that, it has to mix up the letters. So in your random thing for this, it's kind of each character is 1 byte, which is 8 bits. So if you take whatever it's going to be and do this 32 times, it's going to get you 256 bits, and you just kind of have your key already there.
Yeah, I'm not sure offhand. I might have to look into that and get back to you.
Yeah, it's definitely a tangent.
I mean, you're fine. This is the time for tangents. Does anyone else have any other tangents before we take a quick break?
I just had one quick tangent just to reiterate. So it's destructive. The random shuffle is destructive, and the choice, would you consider that also destructive?
Choice, I would say, is non-destructive.
Okay.
Because when I call random.choice die, it doesn't change the die in any way. It just returns a value. And so that value is passed into letters.append, so it gets added to the array. But the die itself is still the same. It's got the same 6 faces on it.
All right, perfect. Thanks.
I was curious about the board. This might be kind of out there, but if we were doing something that didn't require a grid, instead it required, I don't know, a map of like a corridor in a room, could we use that same kind of setup to kind of frame what we want it to look at?
I mean, you're talking about like some kind of dungeon crawl game where you can go
Yeah.
north, south, east, west from any room.
Yeah.
I mean, as long as you never have to move diagonally, an array of arrays could be a good way to model that.
Okay, cool. Thank you.
And honestly, you could even have an array of arrays, and you could have multiple stories in your dungeon.
Stories as in like level 1, level 2?
Like floors, like it's a
Okay,
tower that they're going up. So let's see. How would I do this? So something like that. If you want to make like a dungeon crawling game, you could say this is the first floor or the 0th floor with, it's just a 4x4 of corridors, rooms, and then this is the 2nd floor on top of it. And I guess also in theory, you could model like 4 and 5 dimensional spaces in your game just by having arrays inside of arrays, but it's probably hard to visualize at some point.
Right.
Any other questions? All right, let's take a break. It's 9:45. Come back at 9:55 and I'll probably do another exercise review. At some point, we'll start learning some object-oriented programming. Sorry. Okay, now we're definitely recording this. Thanks for that note. So yeah, I'm choosing to use map here because this more accurately describes my intentions and I think it's easier to read. Great question. Any other questions before I continue? No? Okay. So like I was saying, I need to keep track of the letters in the alphabet. So I can, compare what's 2 ahead of X or whatever. So I'll just declare that in a variable. So I think that's all the letters. But so I don't actually want to deal with the letters as a single string. I want to work with them as an array because, like I said before, arrays are just easier to work with in general. I've got all these handy array methods. So I'm going to split this. So that's going to turn my string into an array of letters. Let me just console log that, make sure that actually works how I think it does. All right, so that's my split alphabet. So I can work with this more easily as an array. I just didn't want to actually type it out like this because it would be a lot more quotation marks and commas, and it would just take a long time and be kind of finicky. But now note, one of the other requirements is that we have to preserve the case. So I need to know for the lowercase letters, what comes after what, but also for the capital letters, I know what comes after what. So there's probably a few ways I could solve this problem. I thought the easiest thing would just be to have 2 separate alphabet arrays declared, and then I can check both of them. So I'm not going to actually just manually define a second array because I can use this first one to create the second one easily. So I'm going to do another map. Say alphabet. This is in all caps. This is my capital letters alphabet. Will equals alphabet.map. So this is going to look through each letter of my alphabet array. And then we're going to uppercase that letter and return it. So now we should get a new array that's the same as our original, just with capital letters instead of lowercase letters. Right. Cool. So here's our lowercase alphabet array. Here's our capital alphabet array. So now I'm ready in my map here where I'm looping through the split input. I'm ready to compare these letters to my alphabet arrays and see what comes after them. Lyman, question?
So could another way you do it is you just do like an if check and then you just take the lowercase letter in the array and just put it to uppercase and compare it to the current index of the string that you're looping through and do a comparison like that versus having 2 separate arrays? Is that another way you could do it?
Yeah, that would probably work just as well.
Okay.
I don't know why that just seemed a little bit more finicky to me. Like there's just more if checks, more nested logic.
Got it.
Thought that'd be hard to read. I haven't tried it that way, so I don't know what that solution would look like when you finish it. Maybe it's better, but this was the first thing I thought of and it worked well enough.
Cool. I was just curious.
Yep, great question. It's always good to think about alternative approaches. So where was I? So we're mapping over our shifted input. So there's 2 cases. The letter is either capital or lowercase. First, I'm just going to handle the lowercase letters. So I want to know where in the alphabet the letter is. So we'll say that location. So I don't know if we've seen the index of method in JavaScript before. It kind of does what it sounds like, but I'll describe it anyway. This will tell us the index of a particular item in an array. So we want to know if letter can be found in alphabet, and also where is it specifically. So that's what index of will tell you. So it's maybe a little weird if you haven't seen it before. So I'm just going to demo that for you really quickly. So let's see. Yeah, we'll just do it with letters. This is simple enough. So ABCDE dot index of C. Sorry, let's get all these other logs out of here. So C is at index 2 of this array, because remember we start counting from 0, 0, 1, 2. Index of E. That's at 4, 0, 1, 2, 3, 4. If we try it with something that does not exist, it returns -1. So that's basically what you need to know about index of. It will return the index of that item, letter, number, whatever, if it can be found in the array. If it doesn't exist in the array, it returns -1. So remember, JavaScript doesn't have negative indexes. This doesn't mean it's at the end of the array. This means it does not exist. You might think it would make more sense for index of to like return false or null or something if it can't find the item in the array. And so some people might prefer that. The argument for this design, though, is that this way index of always returns a number. And so some people like that kind of consistency, that no matter what the outcome is, you're getting a number of some sort out of this function. And JavaScript doesn't have negative indices, so that's not confusing in some ways. All right. So we know how to find the index of things. Letter equals location of letter. So let me see what these locations look like. Okay, I was just counting the letters, making sure this is the correct amount of output. So this looks right. So I'm trying to find the index of each of these letters in my letters array. So capital H doesn't exist anywhere in this lowercase letters array, so that's going to give me a -1. E is the 5th letter in the alphabet array, so that's index 4. L and L are at index 11, so that's what I'm getting here. So I'm getting what I was expecting. Index of is showing me where each of these letters exist in the array. So now all I need to do is just get the item that is further ahead in the array. So that's going to be alphabet, and so we're going to index into it. And that's the location of the original item plus shift distance. Look good? Nobody sees any problems with this? I mean, we're not done yet, but
Well, it's the Z. It doesn't account for the, if it's at the end, does it?
Does not account for the Z. So we're moving everything forwards.
And also like, oh, sorry, but there's also like the letters, the lowercase letters span a certain range of numbers, and then the uppercase span another range, and then there's symbols in between.
We do have symbols. We might not have to worry about them too hard. But yeah, the immediate problem that I was thinking about right here was just the array indexing with Z. Since we're only shifting forwards, if there's a letter at the end of the alphabet and we have to shift it forwards again, there isn't any logic here for wrapping around. So let's see that problem here real quick. So first of all, because this is map, I need to return a value in order to say what goes in the new array. Let's log this. Wait.
So you return the shifted input? Is that what you're trying to return? Or is it, wait a minute, I'm trying.
Yeah, I'm not sure how I got this A here, though. That's not exactly what I was
Because it's
expecting.
-1, you haven't initialized the capital letters.
It is because it's -1. So that's something I need to account for. I'm just getting the location, the index of it. But like I was saying before, if it doesn't exist in that array, index of is going to give me -1. So I need to make sure that that's not the case before I just go ahead and return values. Yeah, that's right. So this returning the letter, the shifted letter, that's assuming that we actually found the letter in our array and that it would make sense to shift forwards. So that means we have to first check that location is greater than -1. Okay, so that's a little bit more what I was expecting. For the capital letters, spaces, that's undefined because we're not able to find that in our letters array. So that's kind of what I'm expecting at this point. I have not yet solved that part of the problem. But I was thinking about the letter Z. So let's just tack a few Z's onto the end of this here. Like we're some kind of like evil snake or whatever. Then if we run that, so just like we were afraid, it's just undefined at the end. So we need some way that indices that are greater than 26 somehow become less than 26, you know? So there's 26 items in the array, 25 is the last index, that should get a Z. So we need some way for index of 26 to be 0 instead, and 27, we want it to be 1 instead. Can anyone think of any mathematical operators that maybe help us do this?
You could use mod 26.
Yeah, let's try that. So I'm gonna add some parentheses there just for clarity that I want to add these first, and then mod 26. So this is going to guarantee that if location plus shift distance is greater than the length of the array, we're going to wrap around to the beginning instead.
Can you explain why that's why that happens when you put the module at 26?
Yeah. So let's say that So there's 26 items in the array. So 25 should be the highest valid index. But let's imagine we're already looking at a letter Z, which has index of 25. If we need to shift that +1, that gets us 26, which is out of bounds of the array. Modulus guarantees that anything over 25, we wrap back around to 0. So 25 + 1, but then mod 26, that'll get us 0. So 25 would be Z. And then
Okay, I see what, okay, that makes sense. It's okay, it's the math, it's doing math there, okay.
Yeah.
I took my brain to.
Yep. It's cool. We don't use modulus every day. Porphy?
Hey, thanks. Will that keep working even like if you get like if the input is super high, like 50 or something like that?
Yeah, that should work. Should be able to wrap around twice, or however many times you need. So I don't know if the shift distance was like 102 for some reason, it should still wrap around as many times as it needs to and land somewhere inside of the alphabet, somewhere between 0 and 25. Okay, so that looks like it handles lowercase letters at least. Now we need to handle uppercase letters. I'm going to do this in pretty much the same way. So at this point, if location was -1, we're not running this code. We have not yet returned anything. So we're going to check if the letter wasn't in the lowercase alphabet. Let's check if it's in the uppercase alphabet. You know, there's only 2 of them, so it's not a million things to check. So then similarly, if location is greater than -1, so did the same thing as the lowercase letters with the uppercase letters.
Raphael, wouldn't it, it wouldn't be if location is greater than -1, wouldn't it be less than -1?
Greater than -1 is correct, because I only want to do this if the letter was found in the alphabet, in which if it's greater than -1, that means it was found somewhere. -1 means it was found nowhere. The problem is I'm using my old location variable. The lowercase location is the first time I checked when I was searching in the lowercase alphabet. The capital letter one was searching in the capital alphabet. In hindsight, maybe I should have chosen different variable names that were easier to talk about, but here we are.
Okay, yeah, that makes sense. Thank you.
Okay, so now we're getting a lot closer. Looks like the capital letters are being shifted as well. So that capital H got turned into a capital I, capital F got turned into a capital G. But now there's still one problem left where we have some letters that aren't in either of these alphabets. So letter is really not the right word. There are some characters that are not in either of these alphabets, such as spaces or exclamation marks. So in this case, if we get through this whole map function, and then if this if statement is false, so we don't return here, and then if this if statement is false, so we don't return here, that means it is neither a capital nor lowercase number, a capital nor lowercase letter. And so we just return it as it is. So if the letter that gets passed in is, space, an exclamation mark, just something that's not actually a letter, there's nothing we can do to manipulate it with our caeser cipher. So we just return the same thing. So that preserves punctuation spaces in our output. Cool. So now we have our output array. Looks like the space was preserved. The exclamation mark is preserved. Everything else has been shifted accordingly. And so the last thing to do is just join this and return it. And join it on an empty string, just sticking all these characters together without any extra spaces created. And then we return output. So let's see that go. And it looks like it works. We've shifted all the letters and then converted them back into a string, which we can return and then print prettily at the command line. All right, so that is honestly how I would write this program if I was writing it for the first time. But now as I'm reflecting on it, I'm thinking that maybe there's some ways I can simplify this, write this a little bit differently. I don't think I need all of these intermediate variables here. Because remember, all of these array methods return arrays themselves. So I can just continue calling more array methods off of whatever is returned and just chaining things like this. I don't need to create new variables for every step. I often like to because it's easy for me to console log the results in between or just put other steps in between if I like. But here I'm pretty sure that this is a good solution. So I'm going to remove some of those intermediate steps and then just do it in one call. I don't need to make a separate variable for the output here. Just put that up there. And so now this whole function is really just this one map call. So honestly, don't even need a variable name for that. We can just return it. Get rid of that. And make sure I actually did that successfully. Yeah, so we still get the same output. But now I've written this in a slightly more concise way. It's a little bit more of a functional style. Input string dot split gives us an array that we can then map over. And then we join the array at the end to get back into a string. The whole thing is returned and we see it at the command line. John?
Yeah, I might have missed it, but does it work in the reverse direction if you supply a negative number?
If I supply a negative number where?
For your the shift on your cipher, instead of going in the right direction, go in the left direction with a negative number. Those are some of our tests.
It might. Looks like it.
Learned today.
Cool.
Yeah, it works.
Am I crazy?
Remember, you're going left, so you're not going to have the same expected output.
I feel like I'm missing something here. No, it seems like something about negative indexes with modulus doesn't quite work. I'm not able to get the A to wrap back around to Z for some reason. So I would probably have to refactor this a little bit to get the negative modulus to actually work properly. So it almost works.
When I was working on this for the pre-work, one of the ideas I had was past, I think it was W, past W, instead of doing the modulus, I went ahead and did minus. So it actually, the math actually worked in the opposite direction.
Okay. Yeah, that could work. It's probably a more thoughtful way I could have done this instead of just using modulus. That would work both ways. So that's a good idea for version 2, I suppose.
If you put an absolute value in there somewhere, it'll probably work, but
maybe, I'm not sure. I'd have to think about that a little more. Did I see another hand up?
Yeah, that was an accident.
Okay. Do we have any more questions about Caesar cipher before we take a break and then talk about object-oriented programming some more? Porfy?
Yeah, I was wondering, how would this be able to handle like a new line character, like, you know, like the slash n or like the slash return, or would that break it?
I have no idea what that would do. Okay, it looks like the new line is considered to be its own letter. I wasn't sure if it would consider backslash as one thing and then n as another thing, but it looks like it's just calling it one new line character. So yeah, it looks like it's working. You know, in the output here, we still have the new line. It doesn't get shifted into anything, but it's preserved in the output. Cool, that was interesting. Any other questions? Question, going once, going twice. All right, it's 10:35. Let's take a 10-minute break, come back at 10:45, and we're gonna talk about object-oriented inheritance. Hello, everybody. Welcome back. Today, we are going to be learning about inheritance and object-oriented programming. I'm sure this is something you've heard a little bit about before, and you're probably slightly terrified. I'm hoping I can make this not too intimidating for you. Just get my editor set up here. All right. So today we will be learning about inheritance in Python. OOP inheritance in Python. So what is inheritance? Generally speaking, we can describe this as inheritance is a way that we can describe relationships between classes. So we've already been designing individual classes, and sometimes they have kind of an informal relationship to each other, you know, our Boggle board or their Boggle dice or whatever. But inheritance lets us formally define a relationship between two classes. So the two classes in this relationship are often called a parent class and a child class. You might also hear this referred to as a superclass and a subclass. So these are kind of equivalent terms. I might actually use both of these phrases at various points during today's lecture. So just know that one is above the other, one inherits from the other. But you might see a few different ways that people describe this. So before I talk about too much more theory, let's actually make a class so I have something to point at and talk about. This might look kind of familiar to you. Make a class for dogs, just kind of representing all the things that they know and can do. Every dog needs a name, so we'll pass that into the init function, and then just assign it to self. Dog should be able to eat. All right, so they can eat and they can bark. All right, so that seems like a reasonable dog class. Just gonna test this out real quick. Just test out my class, make sure it actually works. Cool. This looks like Spot eats a beef. I'm able to create my dog object Spot, call my eat method, pass in argument beef, successfully interpolating the strings here, inserting these class variables or instance variables into this string. And I'm getting my pretty output. Now, just for comparison, I'm going to make one other class real quick. Again, this is going to be similar. So they're so similar, I'm actually going to mostly just copy the dog class. Except instead of a bark method, I'm going to have a meow method. All right. So we're talking about relationships. That's what inheritance is all about. Now, when we're talking about relationships, though, there are different kinds of relationships that we might be dealing with. So something that we've been working with a lot already is something that I would call a has-a relationship. So for example, a dog has a name, a cat has a name. You might also talk about the methods in kind of the same way. A dog has the ability to bark, it has the ability to eat. Okay, so that's a basic kind of relationship. A dog has a name, but that's not what we're going to be doing today. Today, we are thinking of ISA relationships. So we might say, a dog is a mammal, or a cat is a feline, something about group membership. So looking back at our example here, cats and dogs, so there's a lot of similarity between these classes. I'm sure people can notice, I literally just copy pasted the init method, the eat method. There's a lot of identical stuff here. So there's a reason why cats and dogs are so similar, and that's because there is an inherent relationship between these two things. So I would say that a cat is an animal and a dog is an animal. So these are both types of the same thing. So that means that this is a good opportunity for me to use inheritance to describe this relationship. And also another thing that I want to point out is that there are inherent similarities between dogs and cats in the real world. Like in the real physical world, a dog is an animal, a cat is an animal. The similarity doesn't just exist in my program. So I want to contrast that with like a horse and a table both have 4 legs, but that's not actually like an inherent real world similarity. That's just kind of a coincidence based on how I might be describing them in my code. But I wouldn't really want to model those as types of the same thing just because they both have 4 legs. But so anyway, I want to show you how we can use inheritance to write less code. I've written these 2 classes that are redundant because they're both fundamentally types of the same thing. And as such, they have to share a lot of common behavior because they're both animals. Because all animals, let's say all animals have a name, all animals can eat. So there's a lot of repeated code because of their shared behavior. So I'm going to see if there's a different way that I can define these classes that is a little bit more elegant. So just going to comment all that out for now. Try this again. So like I was saying before, the similarity between dogs and cats, and they are both animals. So I'm going to create this more generic parent class that my cats and dogs can inherit from. So I'm going to define the things that they can both do. So the init method was the same for both of them. I'll define that here. The eat method was the same for both of them, so I'll define that here as well. All right. And the cat and the dog did have different, meow and bark methods, but I would like to find a way to simplify this. I want to think of those as being kind of the same thing. So I'm going to give my animal a speak method. Okay. So now I've got, a full proper class. I can use it. Let's see. Okay, so I can make a generic animal, but this is honestly not so super useful. In practice, I don't really want to be creating generic animal objects. The reason why I've made this class is so that I can have dog and cat inherit from it and then automatically gain access to all these behaviors that they should have access to just by virtue of being animals. And then on top of that, I'll be able to define some custom things that are only applying to dogs or cats. So now that I can build off of this animal-based class, I can define my class dog, and here's where the inheritance syntax comes in. We're going to add some parentheses here, and then add the name of the class that we inherit from. So this is saying I'm making a new class called dog that inherits from the class animal. So here we would say dog is our child class, whereas animal is the parent class. So from the animal, it's already got init, it already has eat. I want it to have a different speak method though, because this is not what a dog sounds like. So I'm going to just overwrite this. All right, so let's see what that looks like. I'm just going to make a dog from my new dog class. So I'm calling the dog constructor, passing in a name for my dog. But note that the dog class doesn't even have an init method. It doesn't explicitly do anything with name. But still, if I try to call sparky.eat, it's going to eat some kibble. Sparky eats a kibble. So he's still able to do all of that animal stuff, the things that are not specific to dogs, but that any animal can do, because it's defined on the animal class, you know, the init method and the eat method. So anytime that this dog needs to call a method and it doesn't actually exist on the dog class, well, we can then check the classes we inherit from and see if the method exists there and then use that version instead. In the case for speak though, I didn't want to use the version that's on the parent class, so I've overridden that in the child class. I saw a hand go up just a second ago.
Yeah, I just had a question. Would it work the same if you put the class dog actually inside the class animal, like without the animal as a parameter? Like, does that work the same or is that different?
That's different. That's not what you want here. That's
Okay.
defining a subclass, which I know is something you can do in Python, and I don't know why you would want to. I've just heard about it before, but yeah, you probably are not intending to define a class inside of a class.
Cool.
And then just for completeness, I'm going to define my new cat class as well. Which will also inherit from animal. So now I can make a cat. Seems pretty similar to my dog class. You know, he just inherits from the same animal class, and then you can do all the things that an animal can do. But the reason why I'm showing you this is because like the animal class in my mind is really only useful because multiple other classes are able to inherit from it. If I was only building the animal so that dog could do things, I would probably just put all those features on the dog class. But since I had all this redundant code between dogs and cats, I was trying to find some way to avoid repeating code. And so I was able to make this one shared class, the animal, to keep track of everything that both dogs and cats can do. All right, so I've shown you now how a child class can inherit the methods from its parent. You know, like eat and init. I have not defined those in child class. We just use them in the parent. I've also shown you how we can override a method from the parent in the child. So here I don't want to use the speak method from the animal. I want to replace it completely. So here we've overridden it. So now when I call sparky.speak or garfield.speak, it has no bearing on animal.speak anymore. This method is not invoked at all. It's just using the overridden version in the dog and the cat. But now there's a third situation that's kind of in between these two cases. Let's say we want to use some of the parent's functionality and then also add some more information, add some more logic on top of that afterwards. So I'm looking at the dog class now, thinking, what if we wanted to add some extra steps to the initialization? Because right here, all the dog class or all the animal class has in the init is self.name. Let's say I want to also keep track of service animal status for your dog. So that is one difference between dogs and cats. Dogs can be registered service animals, cats cannot. So it wouldn't make sense for me to put something like that in the animal class, like is service animal. This doesn't make any sense because not every animal can be a service animal. Only dogs can. But that means that I'm going to have to use init in the dog class. So I'll define an init method. Take self, dog's name, and then is service animal. Okay, so what I want to do now is use the parent class's super method, but I don't want to just like copy and paste all the code. I want to be able to just call it by reference. So the way we can do that is by using the super keyword. So super in Python will return an instance of the parent class or the super class. And then that instance is going to have all of its methods, and I can call any of them right here. Joe, you got a question?
Does it automatically call all of it or just one?
All of what?
All of the parents class information, or would it only call like what you specifically dictate? Like speak, would it only call speak, or would it call the whole initiation portion?
Are you saying like when I'm calling speak down here, or?
Well, continue. I think you're going to answer my question in a moment.
Yeah,
Anyway.
I hope so, because I'm not sure if I understand your question right now. Definitely be ready to ask it again if this doesn't make sense soon.
Gotcha.
So like I said, super will return an instance of the parent class. So let's just see that. So I'm calling super. It's giving me a parent instance. I just want to see what that is. Oh. So now I have to actually pass that in. True, Sparky is a service animal. What am I doing here?
Raphael, I think it's because there's no, actually, never mind.
Isn't it missing the true or false for cat too? Is that why it's giving you an error? Like a service animal?
Raphael, do you need to do super dot underscore underscore init underscore name?
I mean, yes, that's the next step, but wasn't expecting it to crash at this point. I just wanted to show you what the parent instance was.
Raphael, I have a question regarding the super thing. And so when I'm looking at this, you have the parent class, everything inherits that. When you go down and initiate or instantiate something under that, if it doesn't have that attribute, or if you want to add an attribute, it's going to check itself first to see if it has it. If it doesn't have it, it goes back up to the top. Is that accurate? And checks the parent class? So like with the speak. So in this case, in the super, what's, I guess I'm having a hard time understanding what that is doing, if it's going to check the top. Anyways.
So I think the issue here is we have our dog init method, but we still need to call our animal init method from our dog init method. Because when we're trying to print out parent instance, it's calling the str method, I believe, or it's calling the eat method at some point. So where are we calling eat? Is that down on? Yeah, so line 57. So when we initialize dog, that is not calling the base init method.
Yeah, sorry, it's just the program's kind of incomplete at the moment while I'm just trying to show you how super works. But we'll get it fixed up in a second. Okay, there, that was all I wanted to show you. So we call super, I'm assigning it to a variable, print that out. It's super class dog. Is this supposed to give you a parent instance? Okay, don't worry about that. I'm just going to show you the correct way to do this. Okay, so this is what your code is actually supposed to look like. We access the superclass, and then we call the superclass's init method, passing in everything that it should need. So remember, if we look at the, looking at the animals init method, that requires just a name to be passed in. So for the dogs init method, it takes name and then also is service animal. But when we call the superclass init method, we just pass in the data it needs, which is just the name. And so that's going to repeat the setup from the superclass. And so then after that, I can just do some custom logic that is only specific to the dog class. So here that would just be setting self.is service animal equals whatever was passed in. And now I'm gonna incorporate that into the speak method. Okay, so then get Sparky to speak. So we can see that the is service animal Boolean did get passed in because it's used in his new speak method. But you'll note he's also printing his name, which we don't assign Sparky's name anywhere in the dog constructor. But because we're calling the superclasses init method and passing a name, the init method from the animal class assigns that to self. So that's doing kind of the first half of our setup, the generic animal setup. And then after calling super.under_init name, we can do dog specific things. Porfi, do you have a question?
Yeah, thank you. So we have to put the name, I guess parameter in both inits for this to work though, right? Like if you didn't have name in the init under dog, it wouldn't be able to pull it from the animal class.
Right. So we're passing in, name and is service animal to dog, so that dog can pass the name in to the animal init. So some things have to get passed through a few times.
Gotcha. Thank you.
Yep. Jesse?
Yes, a quick question on the super. So do you have to do can you just pass in a couple of parameters like name and something else? Say you have more than one parameter in the parent. Would you just be able to do name, comma, that, and it will still bring everything in the parent down there to the subclass?
So yeah, let's say animals also had age that we need when we initialize them.
Mm-hmm.
You say self.age equals age. If we want the dog to also do that, then the dog needs to also have age as a parameter. And then we need to give that to super. And then when we call it, we need to pass that in as well. So dog has name, age, and is service animal. Those three all go into the dog init method. Then we access the animal init method, giving it just name and age, because those are the ones that animal needs, doesn't care about his service animal. And then we continue doing dog specific setup afterwards. Sound good?
Yes.
Cool.
Thank you.
I think there was another hand I saw up.
Yeah. I just had a quick question. Are you able to do like 3 levels of inheritance? Is that possible?
Yes, but can you elaborate more?
Well, like a dog is an animal, like an animal is like a living thing. You know what I mean? Like go up higher. Is that possible?
Oh yeah, for sure.
Okay.
Depending on how complex the program is, you might have many levels of inheritance.
Right.
But I would generally like to discourage you from doing that. If you structure your program so you have like 11 levels of inheritance, it
Yeah.
becomes kind of rigid.
Mm-hmm.
You kind of set yourself up for situations where the boss comes in and says like, okay, there's a change of plans. We're doing this one thing instead of what we were doing before. And then you realize you have just mountains of code that you have to move around because everything is connected in the wrong way.
Gotcha. So I guess my question with that is if you use super and like for 3 levels, it's gonna go to the next one up, right?
Correct. It just goes to the next one up. Now,
Okay.
there are more complex situations you can get into, like I'll show you briefly, where you can have multiple parent classes for one child. So here we have multiple children for one parent. You can also do the other way, multiple parents for one child. And in that case, it's a little bit less clear what class super will give you. There is something in Python called module resolution order, I think is what it's called. Actually, let's just go to python.org. Wow, so this is way more verbose than I was expecting. But basically the idea is when you have a really complex multiple inheritance situation, there is a defined order in Python for which superclasses it checks in which order, depending on where you call super from. So I don't know what these rules are offhand. I would typically use inheritance in simpler situations where there's only one possible superclass, or I would just explicitly name the superclass that I want to inherit from. But it's certainly possible if you were building, you know, a very sophisticated application that had lots of inheritance, you might have to rely on the module resolution order so you can call super and have that refer to the right class. So that's more common, I think, like in game development, you'll have many types of things and many subtypes of your types of things. But as a web developer, I don't do that as often. Was there another question? Thought I saw some hands.
Hi, Raphael. So if we have multiple parameters there, where you have like the name, age, what do we do? Can we put like the dot or?
Like if you have like 100 parameters or something, do you
Mhm.
mean?
Yeah.
I mean, you could probably do star args like that, and then pass in however many other arguments I want, and then I'd have to put some logic in here that does something with star args. I can't think offhand what I would use that for, but it's possible.
Thank you.
Any other questions before we move on?
Could you re-explain what super's purpose is again?
So the idea is that here we are in the child class, and I want to access some logic from the parent class. So like, let's say here the init method is very short, but let's say that this was a much longer function and I didn't want to copy and paste all that logic. What the super method does is it lets me access those methods from the parent. So the first thing that I do when I'm setting up a dog object is I just want to repeat the setup for an animal. So calling super.init name age is just calling this method from the animal, but I'm calling it when I set up my dog. So it's like I'm doing the animal setup first, and then I do the dog setup afterwards. But I do it without like copying the animal's setup function. I'm just referring to it directly.
Okay, thank you.
Any other questions?
I'm kind of confused on like 46. You're getting, I don't get why 43 and 46 are needed if the self name age, like that part confuses me.
So on line 43, this is just the setup for the dog. So if I wanted to, I could just repeat everything that the animal does. Just like literally just copy this over. And so this would be like an alternate way to achieve the same functionality. But the problem here is just that I've duplicated code. Is that I've like copy and pasted the animal init method into the dog init method. So I would rather, write this once and then call it wherever it's needed instead of writing it multiple times. And so that's what super does. Super dot under init lets me reuse this method from the animal. So it basically just lets me do self.name equals name, self.age equals age, but I'm doing it in one line here by referring to the animal instead of, just copying the code in here. It's just to avoid duplication. Does that help?
Yeah, I think so. And then you could do that for like the speak method or
Right, potentially. Like if the way that the dog speaks is the same as how the animal speaks, but then he does more stuff extra, then you could potentially use super. In this case, the dog speak method is just entirely different. So I didn't use super, I just overrode it. But we could also use super. And so then it would print, I'm an animal, before printing whatever the dog is supposed to do specifically. I mean, I guess we could even see that. Super dot speak.
So do we have to call from super in every method in order to use it, like you're doing right now with speak? So do I have to do that each time in each definition?
If you want to utilize the behavior from the parent class, then yeah, you have to use super. Otherwise, if I actually, I wonder if it'll be a problem that this has the same name as the parent method. Oh, no, so that works just how I was hoping. So I created dog Sparky, I tell him to speak, but first I use the super speak method, which is just print I'm an animal. And then after that, it does the normal dog things, just because that's the next line of code here. If it's a service animal, say you're here to help, otherwise you just bark. So we're doing both of those, the base animal speak followed immediately by the dog speak. So yeah, you can use super for any of the methods where you want to use the base functionality and then also other stuff.
So I could have like a standard greeting in the super class for everybody who comes into like a program or an application, and then based off of what their child class is, then that would dictate kind of the interaction from that point.
Yeah.
Is that correct?
Yeah, so maybe the base class just says hello, so that like anyone that inherits from it, they're going to have a greeting that starts with hello, but then they have some other more specific follow-up to the greeting, like hello, how you doing, or hello, how's the weather, or whatever. Hello, how are you kids? I don't know.
sorry, just to clarify, so super is only if you want to modify the parent class, like more in depth.
Right.
Okay.
Because without using super, where are we? So like for this example here, without using super, it's a good example. So I guess on the cat, speak is completely unrelated to the animal speak. I just wanted a totally different function, so I've replaced it entirely. Since there's no call to super in here, this doesn't have any effect. This doesn't relate in any way to the animal speak method. I've replaced it completely. And then, also the cat has access to eat without using super, because I didn't need to modify that at all. I was happy to use the animal's version of eat just as it is without any modifications. So without using super and without even declaring it on the cat, my cat can use eat from the parent class. So it's only in cases where I do want to utilize the parent's functionality, but I want to do more than just what the parent does, that I would use super. So it's pretty common, I think, in the initialization that the parent adds a bunch of properties and then the child adds a few more properties. But you can also use it for methods like we see here. Any more questions?
I have one question on the distinction, because we're using the same terms in both the self instance and the higher class instance. Do we need to have them in the individual instance of a dog? I guess in my head, all animals dog don't have a name. They're called dog. The instance of a dog has a name. So things like height, age, gender would be in the class. If I want to inherit those in the individual dog named Sparky, then I use the super method to initiate them without having to write it in the self instance.
So just to be clear, I haven't defined any class properties. There's no properties on the dog class itself. Everything I've defined here, name, age, of service animal, these are instance variables that belong to each individual dog.
Correct. But if the parent has those, like, do we need to name them again in that particular line? Like, because for me, I'm seeing the same thing in terms of
Oh,
words,
like the
maybe.
repetition, just like
Yeah,
name,
so
age, you're saying?
It's confusing me a little bit, whereas the animal, the class animal would have height, weight, gender, those types of things. The individual dog would have a name and inherit all of those other attributes.
Mm-hmm.
And is that how I would use the super? So like Sparky on line, whatever, on 43 would have a name, and then I would use super, init, height, weight, gender, other attributes from the parent without having to write them in the individual definition of a single dog. If
So you're
that's
saying, like,
clear or not.
when you call a dog here, you saying you just want to say Sparky?
So if we go up to line 43, I think it is, and we say the only thing in the instance of a dog is a name.
Mm-hmm.
And is service animal, I guess, but for this case, I guess just name. And then we go back up to the animal class and we get rid of name, but we have age, gender, height.
Mm-hmm.
If I then go back down to the dog instance and I do init, super init, then I can do gender, height, age, I think is what we had up there. And I don't need to write it in the top part of that self instantiation line.
Sorry, this isn't going to work the way you're suggesting it. Because where do these variables come from? Gender and
From
age.
the super class, like the parent. That's why I guess I'm having trouble understanding what you're gaining there.
So we don't know specific values for gender and age until it gets called here and they get passed in. So, here's age and is service animal. We don't have those specific values until you call this dog constructor. So those would all need to be named in the dogs init method. Anything that we pass in when we call dog has to be part of the dogs init method. And then the tricky thing here is that the supers init method doesn't use the same parameters necessarily. It's going to use fewer parameters than what were passed into the dogs init method. So Python doesn't assume automatically which subset of these variables are needed for the superclasses init method. So you have to manually pass them through. So it's a little unfortunate that it doesn't, automatically do all of the setup for us. There are some things that we need to specify.
I have a question. So if you omit name, I mean, you have to pass in every single parameter from the superclass in order for it to function correctly in the subclass. Like, will it throw an error if you don't pass in age, for example?
Here?
Yes, like if you didn't pass an age, will it throw an error?
Should.
You remove from init line 43 as well. So you remove the age for name, yeah. I'm just curious.
So yeah, I'm expecting that'll fail because we're calling super with just name. But the animal init method requires name and age. So there should be a similar error. Yeah, it takes 3 positional arguments, 4 were given.
Got it, thank you.
Justice, you have a question?
Yeah, so I'm just making sure I understand this because I think I'm seeing like a lot of what's confusing. So when you're declaring, say in dog animal line 43, when you're declaring that init, basically what you're doing there is saying when you declare dog, whatever dog's name is, right? In that instance, those are all the variables that have to be passed in. Now, when you declare the super function, all you're doing is taking those lines of codes that say self.name, self.age, and obviously like those aren't a lot, so it's not super useful. But if you had like a lot of things that you wanted to pass in from the parent function, all it's doing is taking the self.whatever and doing that for you, so you don't have to repeat it, right?
That's correct.
Thank you.
Yep. So yeah, that was a good description. Thanks for saying that back to me. I always like to hear people explain concepts in their own words, just so I know that we're on the same page. Bao?
Just to clarify, when you declare super init, the attributes in it, so does that mean they have to be the same as the other init on line 43, like 46 and 43? Does that mean the first init method has to have the same attributes as the super init attributes?
I will say this one will have the same attributes and more.
But the name and age has to be included because they were in super.
Yeah.
Okay, thank you.
So that's one maybe little and kind of unintuitive thing about inheritance is that the child class is always bigger than the parent class in the sense it always has more stuff, because it has everything the parent class has and then some extra stuff that's specific to it. So, usually you think of children as being tiny humans and parents are much bigger. But in programming, the child class is always going to be bigger, has more features in it. All right, so I've been showing you how we can have 2 classes that inherit from one base class. I'm going to do something a little different now, and we're going to have one child class that inherits from multiple parents. So going to just define a couple of simple classes real quick. Got a person class. missing here?
You've got that extra colon in the after the init.
Oh my gosh, thank you. Oh wait, that was the wrong colon. Okay, there we go. I swear I know how to code. All right, so we've got a pretty basic person class. This is probably the third time you've seen a person class already, so I'm not going to talk about this too much more. Let's also make a class for a computer. So, you know, some computers are faster than others, depending on how many cores they have. Of course, if you're a computer, you can compute. Going to do a little bit of quick math here for our computing. All right, so our computer is just going to print out pi, and then we're going to round it down to the number of cores. So, you know, obviously, if you're a faster supercomputer, you can print more digits of pi, whereas a weaker computer is not able to do that. So let's say toaster equals computer. It's got 1 core. Say toaster dot compute. And we'll have copy 386 is an 8-core computer. We'll get the 386 to compute. Okay, amazing. So with all that extra processing power, we can compute, you know, 8 digits of pi. So I've got a person class, I've got a computer class. Let's think about relationships again. Can you think of something that both is a person and is a computer?
I mean, we're
Mark
kind of like
Zuckerberg.
computers.
Cyborg.
Cyborg. Okay. So let's say for some reason, we're writing a program that has to model like the Terminator movies or something. We might need a cyborg class. Now, of course, this movie also has lots of people in it. It also has lots of computers. And, you know, the Terminator can do anything that either of those can do. You know, he can do anything a person can do, but he's also got that built-in computer, so he can compute pi without taking his phone out of his pocket or whatever. So yeah, we're going to build a cyborg class that inherits from both person and computer. So we're passing person, and then just separated by commas, another class. You can inherit from as many different classes as you want, just in a comma separated list like that. So the cyborg needs to have all the parameters that both a person and a computer have. And then I'm going to call both of their init methods.
And the reason you have to do that is because it's inheriting from more than one class.
Right. So yeah, in order to initialize a cyborg, which has name, job, number of cores, I'm going to run the computer, or well, first we're going to run the person init method to assign their name and their job. And then I want to run the computer init method, which will assign number of cores. So I just directly invoke the class and then grab the init method off of it, passing in self-name job. And then do the same thing with the computer, passing in the variables that the computer cares about, which is just number of cores. And now if I want to overwrite this method, I can do that, or overwrite some other methods, I can do that. I'm going to say you should have a different work method, because if you're a cyborg, you're much more efficient than regular people at working. So I'm still invoking the work method from the person, because I've just manually grabbed that class and I'm calling their work method, but I'm passing in self so that the cyborg is performing the work method, but also because it's inside of his own overridden work method, I can add some custom logic. So we're going to do it in a loop for however many cores he's got. Because if you're a 4-core cyborg, you can work 4 times faster than a regular human. So let's try to actually use this class here. Say Terminator equals cyborg. Name is Arnold. His job is Terminator, and he's got 12 cores. And let's see him work. And let's see him compute. Let's get these out of here. There are other calls here. At any rate, so Arnold can compute because he is a cyborg, or because he is a computer. I didn't define the compute method here, but because he inherits from computer, he can do anything a computer can do, like compute. So without actually defining compute on the cyborg, he still has access to that. And we saw here he has access to the work method, which was defined on him itself, but it does use the person class, even though it also accesses his own data. So we're looping 12 times, show he is working hard as a Terminator 12 times faster than just a normal human could. We saw a few hands go up. Questions? Bao?
Oh, sorry, I had a quick question. Like, is there a reason you didn't use super here instead of just putting person.init and compute.init?
If I used super, it would refer to one of the specific parent classes. I'm not exactly sure which one. It's probably person, I think, because it was defined first. There's a way that you can use super to specify which parent class you want, but I could also do this. This felt simple enough to me. Because I'm not like designing some like super generic structure of parents and parents and children up 10 levels where everything needs to refer like abstractly to others that it relates to. I have exactly 3 classes in this situation and I know how they relate to each other. So I'm just gonna call them out by name.
Okay. Does that mean a super most of the time only refers to one parent class?
if you call, where did I do that? So yeah, if you call super with no arguments like this, the default behavior for super is to follow Python's module resolution order. So calling super with no arguments, and it follows this Python module resolution order to figure out which the next super class is. There are also ways that you can pass arguments into super to specify which superclass you want to use. That's not super commonly done, I don't think. Mostly people just use it like this when there's only one superclass that it could choose. But yeah, I just felt like it would be kind of confusing in this situation and here. So this seemed like a cleaner way to write it, in my opinion. But it depends on the context and the problem you're solving.
Thank you.
Got 2 more hands up.
Rob, you can go first.
All right, thanks. Raphael, do you mind going back over, say, if you were trying to keep track in your parent class of both computers and persons, and say our cyborg instance was one of those, and you had like a list in your parent class, like how you would append, like every time you made a new instance of cyborg, how you would append that information of each individual cyborg for the in each one of those lists.
So you're saying every time I make a new cyborg, you want to keep track in the computer class that we made a new computer, and in the person class that we made a new person?
Correct. Or just one or the other, like if, we're trying to do that for, like, say, the school teacher student kind of example later today.
I think I would just do something like this. People, computers is empty list, and the cyborg init. We can then Yep. So here, printing out computer.computers and person.people, it gives me the same result both times. It's a list with one item, which is a cyborg object. So I think that accomplishes what you're asking for. This is
Thank you.
probably how I would go about it.
Can you show us how you did that again? Can you scroll back up to was it just a list?
Yeah, so yeah, they're just lists. I used a class variable here for people and computers. So these are variables that don't belong to any individual person or any individual computer. It's data that belongs to the class as a whole to kind of keep track of meta information about the class. And then when I initialize a cyborg, I just manually append to those lists, because I've already got references to person and computer here. I've called their init methods. So I can access the arrays on them just as easily. Do we have other questions?
Yes, I was wondering about super. Is there an advantage to using that over just naming the class?
In some cases, it might be more clear to use super. Like if you have, like 11 classes or whatever in your program, and you just explicitly name one other class in an init method, I might be wondering like, well, what's the relation of this class to the one that we're in right now? Like, is this the parent? Is this the grandparent? Is this some cousin class? Is this like completely unrelated and we're calling its init method for totally wacky reasons? Or is this just conventional object-oriented inheritance? So if I just see, where are we? So if I just see the super method being used, then I know that this is pretty conventional object-oriented inheritance. I don't even have to think too hard about what the parent class is. I just know that like, oh, okay, we're calling the init method from the parent class, so it gets everything they've got, and then we're doing some extra stuff here. I don't have to think too hard about the inheritance tree while I'm reading the dog class. Whereas for the cyborg class here, we're just explicitly naming person and computer. In order to make sense of this code, I have to know something about the relationship of my classes. I have to understand that person and computer are both parent classes of cyborg, and that's why I'm calling them here specifically. So it makes the relationships less obvious. It depends on what you're trying to communicate with your code, I suppose. Does that help?
Yeah, thanks.
Cool. I think I saw another hand up. Nope. Okay. So
Rob, your hand's still up.
My bad.
Cool. So for the rest of today's lecture, I'm going to show you inheritance in JavaScript. It's like 99% the same as what I just showed you, except there's a slightly different syntax for it. So I'm just going to show it to you briefly so you're not surprised when you see it in other projects or whatever. Okay, class animal, it already looks the same, right? Okay, but now we have to put some braces in. So instead of the init method, we have constructor. We assign to this instead of assigning to self. Define methods, just like so. Don't actually even need any keywords. Don't need def or even like function or whatever. Cool. I want to make a dog class. So here's the big difference between Python and JavaScript. Instead of using the parentheses and then passing in the other class, we have a keyword extends. And we still have the super keyword. So just like in Python, we have super in JavaScript. So this is going to call the constructor function from the animal class and apply that logic here. So we don't have to repeat this.name equals name. And yeah, the rest of it is going to look pretty familiar. So that's inheritance in JavaScript, very similar to inheritance in Python. It's really all the same concepts. So I'm not going to dig too much deeper into that. Just know that if you see this syntax extends, this is inheritance, like you've learned about. I actually kind of like this terminology, extends, because it makes it clear that the dog class is bigger than the animal class. It can do everything and more. It's an extension of it. So I feel like that sounds more like what it does. But child class, parent class, superclass, subclass, those are also very common ways to describe these kinds of relationships. Okay, so very last thing that I've got for you all for today's lecture, I wanna ask a question to you all. Based on what you've seen here, what would you say, when would you use inheritance? Like if you're in an interview and the guy across the table is like, okay, inheritance, but when would you use it and why? How would you answer that? Excuse me. Rob?
When you're trying to go from like a more general but similar characteristics kind of object down to then more specific, unique types of objects.
Well, why? Why do we care about that? Why does that matter?
I mean, I would say organization. I don't know.
Okay, yeah, it's always good to be organized. We've got a bunch of hands up. Let's hear some other suggestions.
I would say that just if you're asking about a company, you're going to have different types of employees, supervisors, administrators, admin, finance, all that kind of thing. Certain job roles will overlap, have similar functions, and you would use inheritance to specify basically the master portion, or like a master of what everyone would do, and then you would list out from there the other classes you could use based on what role they're going to have.
So I feel like you kind of described it. You didn't say it quite so explicitly. So let me be clear about what I think is the great part about inheritance, is that inheritance lets you write less code. So I know like all we've been talking about today is modeling relationships and stuff, but you shouldn't just be trying to model relationships in your application. Like if you're told to build a program that has dogs and cats in it, like you shouldn't automatically think like, oh, dogs and cats are both animals. I should create an animal based class and have my dogs and cats inherit from them. Like you should build your dog and cat classes as simply as you can, and then reflect on what you've built and see if they actually share any code. There's a very good chance that in your program, there aren't actually any inherent similarities between dogs and cats. They don't need to share any code. And so you'd be perfectly fine making two separate classes for them. And another example I like, I think I mentioned this before, but if you have like both dogs and tables in your application, like both of those have 4 legs, you could potentially have a class called 4-legged that dogs and tables both inherit from. But it's very likely that as your application grows and your needs change, that there will be more and more differences between dogs and tables, and it'll make less and less sense for them to inherit from a shared base class. So I really want to encourage you to make sure that when you use inheritance, there is some like real permanent relationship between these things that can't be changed suddenly because your boss comes in and says the requirements are a little bit different today. And also, you should make sure that you're actually writing less code as a result of inheritance. I've definitely seen people go way overboard with inheritance. They just want to describe all the relationships between all the different parts of their code, and they end up with just way more code than if they had done things in a simpler way. So for all these organizational techniques that we're teaching you, like they're not really valuable in their own sake. They're valuable because they enable you to write less code. And then if you have less code, it's easier to organize, it's faster to read it, it's faster to test it. Just everything in your life is easier if there's less code in the application. Sorry, there were a whole bunch of questions. There were a whole bunch of hands went up while I was giving that spiel. Jesse?
Yeah, no, I was just saying with inheritance, what I thought was important is it's like a template to kind of have for let's say a group of people or an application that you want to work on, and then from that inheritance you can adapt to it on whatever instance that you want to go off of for that particular parent group. So I look at it when I think of inheritance, I think of it as a template to start things off, and that's why coding is simpler that way.
Yeah, that's definitely a good description. I mean, certainly that's why we use templates in many cases, is that they enable us to write less code. You can define a template for common features and then just kind of stamp them out everywhere we need to. So yeah, in a lot of ways, inheritance works as like a sort of templating kind of system. But again, I want to drive home that the goal is to write less code. If you're considering any of these strategies or approaches that we showed you, and you think it's going to result in a considerably larger application for no other benefits, then maybe consider doing something simpler. Any other questions? Don't have any other content for you today. We can just open up for questions or release you to work on your exercises.
I just wanted to verify that you're going to push that code up for us to look at.
All the demos and notes, everything I wrote today?
Yes.
Yeah, that'll be in the demos and notes repo. I'll make sure that that's updated. Yep.
Just to clarify, so yeah, there's some issue with our challenges. So again, Boggle should have been yesterday. App users 3 should be for today. Again, we got to get this straightened out. But so I think currently it says Boggle for today. I mean, you guys can work on it if you guys didn't finish yesterday. But there's an app users 3 challenge, which is a continuation of the last 2 challenges that deals with inheritance. So we're gonna have to figure that out. But just want to make sure challenges are straight there.
All right. Thanks, Ankur. Oh, Marcus, your hand up.
Yeah, I had a question. So when we just went over OOP and JavaScript, we called super. Hold on, sorry, my question is from a few minutes ago. I got to rethink of it.
Sure.
So going back, if we call super in Python, we can call the methods that come from the parent class. But in JavaScript, how would we do that? Because is super in JavaScript just referring to the constructor method on the parent class?
I do believe so. So you're talking about how we use super in Python, where we would, like for speak, use the animal speak and then have extra text afterwards.
Yeah.
I'm sure there's a way to do that in JavaScript. I'm not sure offhand.
Okay, no worries. I just wanted to make sure I didn't miss anything.
You didn't miss anything. I didn't explain that while you're sleeping. But that's definitely a good question to have. That is something that you should expect from your language, I would say. So, if you're learning some new language, you should say like, oh, I know how to do this in Python. Can't we do this in this other language? That seems reasonable, because most programming languages are more similar than they are different. Any other?
Thank you.
Yep, you're welcome. Any other last minute questions? All right. Thank you very much, everyone, for coming to today's lecture. I hope that was interesting and useful for you. Take a full lunch, come back at 1-ish, 1:15, whatever you feel like. I will Slack out pair programming partners between now and then. Use today's Thursday. It's a pair programming day. I don't think we have any other content scheduled for you this evening. So just come on back at 5 for the stand down. Thanks, everybody.